Okay, do you hear me?
Oh, that's amazing. Yeah, that's much better.
Okay, that's good.
Brilliant. Ah, perfect. Can you sort of talk to me about your role at Pickle and what area you specifically
Yeah.
focus on?
Well, I'm the product manager for piql. We're a small company. We are 16 people. Most of the team are R&D, a little bit more than half. The rest is business development and marketing and product management. So just I'm basically the interface between the techie guys in development and the sales, Georgie, and the manager. So I'm a little bit in between. One of my functions, as you can imagine, we're developing a new technology is working with marketing in order to create that strategy to go to market. Events, pricing strategy, education of the partners. So I mean that sense, defining what features are needed according to what the sales guy tells me, talking to partners, talking to customers. So that's my role.
But I'm quite interested in how Pickle moved from Cinnovator into what you're doing now with digital information preservation. And I just wonder if you could just speak about that, like talking about Cinnovator, what that is, technology, and then moving on to how that developed into Pickle, what we now know, what you're doing now as a company.
Okay, perfect. Miles, everything start. Our general manager is the founder of the company. He comes from automation and projection. High-end projection.
Yeah, okay. Yeah,
Projectors is. So he decided one day, well, for any reason, he get into the film industry. Some colleagues, and he started to find to he identify a need that was how to distribute film into the analog the projection or the projectors that were analog to for cinemas. So he came to an idea because he has a lot of experience in projection and automation, and at that time creating copies for the theaters, uh, just one copy could take even 3 weeks to make the master. Of course, there were machines where they call it contact printers, where you can make more copies very fast. But then it was a very expensive process, so he decided to start thinking on this. So what the original. So this machine, the Cenevator, was created just for to make the positive prints, which are the prints that goes to the theaters. Is The technology changed completely. He used one frame size DLP. It's basically at that time it was a 2K resolution. Is actually the digital lighting processor that is in the digital process projectors. So basically,
yeah,
these devices are, imagine like millions of micro mirrors that you direct light, and then you modulate the light, and then you can create the image on film. Use different colors, well, the three primary colors as a light source. Then you hit this device, and then you create the image. Like it was one frame, he could create in 1/24th of second each individual frame. So the machine could print 24 frames per second. So you can create a 2 hours movie in 2 hours
yeah,
time. So from 3 weeks, he moved the production to 2 hours.
yeah. That's amazing.
Yes, and the downside is that when he created this machine, the analog market was start declining. So
Yeah,
it wasn't market at least for a decade, but definitely digitization was going to take over. So that was what happened. He developed this company. It was a breakthrough. Most of the big studios use it, Hollywood, Bollywood, uh, through other companies like Technicolor, like Deluxe. So they were producing for these big studios. Disney used it. So basically, that's the way they developed the product. Was very successful. This product was sold as a hardware with services. So the partners were buying it and then serving their customers. So what happened? This machine has something. For example, when you make the color distribution or print, positive print for the theaters, we could put at the same time the digital Dolby stereo on the perforations. So you look into the frames in cinema, you see the frame with the data, with the image. You can see the audio in analog, like the wave, and you can see the Dolby stereo between the perforations. So it's actually zeros and one. It's just grades of level. So you see like a QR code between them. So there is a synchronization, and we could put any subtitles at the same speed.
Oh, okay.
So that the movie was prepared with subtitles, with full color and Dolby digital sound.
Yeah.
So he started to develop, well, what should I do with this? And then it came the idea of, okay, we put Dolby digital, why we don't expose digital content? And digital content is any file is basically a stream of binary code, zeros and one. Any file and the attributes, the color, everything is written in zeros and one. That's the language of the computer. So if we take that stream, well, we don't expose it, and of course we're not going to write zeros and ones. Our representation of zeros and ones are gray levels. Okay. So he started a project with that Cinevator I was called the Keeper.
Okay.
But for some reason, the company, I wasn't here, but the company started a research project with Eurostar, where around 15 partners start to put the knowledge, got together to develop what is piql. It was decided that we needed more resolution. We needed a different type of machine. We needed to focus on a black and white 35 millimeters film, because the color film that is managed this machine is not suitable for long-term preservation. Okay. The color, the dyes, so the emulsion that covers this is estimated to last for 100 years because of the chemistry of that emulsion. But with the black and white, we have a silver halide that is very stable, and it has been tested and proven to last for more than 500 years. And even the polyester base is more than 1,500. So that's why microfilm archivists, people trust the black and white film.
Oh, okay.
So we needed to move to that, meaning we don't need 3-color light. We just need 1 color. We developed our own film to have better resolution, less noise. And then we could make this zeros and one smaller with a high definition so we can read it. And that was the moment where we transit from this machine to the piql. And we put a little bit of design so the machine is more, it's not like this one that is vertical, it's more horizontal. And it's several technical changes to make it a little more, or I would say faster, a lot of improvements on the gate, so we have better quality with speed. So in short words, trying to make it better, the performance, and that's what we did. Then in 2014, we decided to change the name of the company, because like we were in the movie industry or the motion picture industry. It was Cinevator. Cinevision was the company, Cinema Innovation. We got in a new industry, which was digital storage. So we can store film, but we can store information from banks, from pharmaceuticals. So now the range of industries is broader. So the Cinevision name, it wasn't really appealing. So it came the name piql. And the piql is more a brainstorming. It has a nice logo on short that have a loop. It's from zeros and one was made, and also sounds like pickles, like the preservation of food.
Yeah.
So it came a lot of.
So it doesn't mean anything. Pickle
doesn't mean it's an allegory to many things, and then it was catchy. Then we changed the name to the company to piql, former Cinevision. And that's why we moved completely from production and motion picture for distribution to digital storage, focus on digital preservation, and that was the transition.
It may have been something that Cinnovator did in the past, but I understand that digital films, digital movies, are stored on a like a tricolor acetate film for preservation.
Yes, yes, it's called color separation. The fact that the industry, the motion picture industry, trusts film because it's a medium that had proven to last. So for several years, like today with digital technology, they can keep the masters on LTOs or hard drives, but this has the problems of obsolescence and problems of losing data. So there is a lot of fear in the market to keep the master of movie sounds on normal storage mediums, digital storage mediums. So there is a technique in which after you have made your movie digital edited and you can distribute it and play it on digital projectors, what they do is that they use a black and white film and they expose with the three primary colors. So basically, you take a black and white and you, from digital, you make imagine that there is a digital transformation to frames that are exposed on film. It's just light exposed on film. And they do something that is in three colors, that is cyan, magenta, and yellow. And this is the opposite to red, green, and blue. So when you do cyan, so basically you take a black and white, exposed with that cyan light, and it creates some images. When you have those images and you scan it in the future, it's like a negative, it changed to red, green, and blue. So imagine three films, black and white, with different lights that are the opposite to red, black, and blue. So you need, in order to keep that, you need just three films of the entire movie.
So why do they do that then? What's the reason for?
Well, the main reason is that they don't trust the current storage mediums. And the reason is that you have, in this industry, and most of the industry, they use LTOs, magnetic tapes, because the magnetic tape is the medium that is proven to last the most. But still, these digital technologies are prone to losing data. And another thing is the hardware around today's technology needs to be updated. So LTO technology, for example, today is in version 7. You need drives. Actually, you need some technology drives to be able to read that tape and software. What happened is the manufacturers they want to sell more products. So each 2 generations doesn't support the previous LTO. So even if you have chosen a file format that you believe this is the preservation file format accepted by all the motion picture houses, the hardware forces you to migrate, meaning that when you're in version 9, it support the 9 and 8, but not the 7. So you will LTO version 7, you cannot put it in the drive, it's not readable. So you are forced to move that digital information to a new LTO because the others are out. When you're transferring this information, you risk losing data, to have errors, to have mechanical and hardware errors, so you can lose data. So you need to have a lot of backups and a lot of management. Because when you and I are updating our external hard drive at home, it's okay, it's one. But when you're talking about data centers, terabytes and petabytes of information, you need to recheck, check some that everything is okay. So that fear of losing information is what is creating this lack of trust in what is today. And that's the reason why they say, okay, let's put it in visual, in a medium we trust, that is film, that if we take it under the good environmental condition, it will last for hundreds of years. It's something we can see, and the digital technology will be in the future, so we can take it back to digital, edit it. You always have a little bit of loss, but they take that risk instead of putting on LTO.
Um,
So that's why they use the old technology to preserve digital content.
and so what do they do with all these films? These when they've transferred the digital film onto film, what do they do with them? And
Well,
do they store? I mean, obviously they store them, but do they do this for all digital movies now?
today we have been talking to several houses like Warner Bros, like Disney. They continue doing this. All the masters, all the movie masters are changed to digital separation. What they can't do is do the same with the audio. So they can take the picture. This is a preservation of the picture, but the audio they preserve it in the magnetic tape.
Oh, okay.
So we have come as a solution for the audio part for the moment. So it's good because now they have film, digital, and they can put the sound. But we can come back to that. What do they do today? They keep it in their vaults. So physically, they take the reels. One movie could be, depends of the size, but it could be 18 reels because the reels they use is like 20 minutes movie. So you have an hour, so you have three, you have a 2 hours movie, it's like 6 times 3, it's around 18 to 20 reels. They put in a vault, and those vaults are humidity and temperature control. 50% relative humidity is the standard, under 21 degrees Celsius degrees, and they control dust, they control, they have security, these things like that. But the most important is control the humidity and the temperature. Basically, they keep it, is what they do.
So they're very much the movie industry is doing a similar thing to what Pickle's doing with information, but they're doing it with their information as moving image.
Yeah, exactly. But they just do it to the movie and what they call the master, because you have the distribution. And to distribute, they lower the quality. They compress the movies, because when you are shooting in digital, you can have raw images. So they love to have the highest quality. But when you're distributing, you cannot use those files because they are huge. So they are a standard file formats for distribution, which they send to the cinemas with security codes for copy, for avoiding copies and things like that. But then those copies they don't consider for preservation because they have lost a little bit of information. So they keep this master, these raw files. So they are very big files that and the cost of putting on film, doing this digital separation that just do the movie, they just take the master movie. They today have all these delete scenes, and today in digital they just leave the camera rolling.
Yeah.
And they are so afraid to delete because they can use it for maybe getting something back in the future. So nobody knows what to do. So they take just the master and put it on film. The rest is in magnetic tapes,
Yeah.
and risking to be lost. There is no like film, and especially film is analog. So the light is capturing all the details. And that's why the directors love film, because you have all the range of color, the dynamic range is so good. When you are sampling them in digital, you normally lose some quality. When you take the best file format, that is raw images, you capture the best. But it's always a little loss when you compare to reality because of the sampling. Then what happens is that you have that master, you need to digitize and convert it back in something that render that we're gonna post on film. So it's always a little bit of losing information from reality, maybe not perceivable by the eyes. But then you put it on film in 3 different films in black and white that later you're gonna scan it. The process of scanning, you always the optics, you lose something in resolution, not too much, but then you have in digital 3 three different scans that you need to overpose by software, to digitize, to fix a little bit colors because it's not perfect. So it's the best way because of the median. You can trust the median. You have the best representation of the image, but every time you have some edition, it wouldn't be the same representation of the real analog image on film. So there is a little, it's not perfect. It's not perfect, the process, but it's the most trusted within this industry.
And so, I mean, it's been really interesting talking about that because, that's a good way of sort of thinking about what you do at piql. I mean, at piql, do you have any of those issues in terms of going from digital information onto film and then being able to read that information back,
That's a very good point. Actually, we don't have it because what we take is the zeros and ones. So for example, and people sometimes say, well, how you do? You're putting it in black and white. Because if you give me an audio or you give me a PDF in color, and then when you look at our film, you see just some strange dots. It's not understandable. So it's like those magnetic particles that I mentioned on the magnetic tape that takes zeros and one. What you see is gray levels, which identify zeros and ones. So for us, we just need to scan it again back, identify those values, that this light gray means 00, the dark gray means whatever. It's a stream of data, so we convert the file exactly the same as the original. So we don't lose anything. You lose when you are moving to analog. So if I have a digital, I expose it on the film. When you look in the computer, the quality is amazing, colors. When you put it in black and white, well, what you're gonna have is a black and white image. If you scan it, you have a representation of your color PDF, but it's black and white. You might see a dust that was a stick when scanning. You can have some defects that people normally you can fix it digitally. But what happened is that what we retrieve is just zeros and ones, and we have a decoding software that builds against your PDF. So it's exactly the same file. So we are just the storage medium. So think of us as a big magnetic tape, but it's optical tape. So it's not magnetic, it's just based on optics. Imagine a hard drive, it's a big hard drive. So we try to explain to people, we're just a storage medium. So there is no loss on quality. One of the advantages, because people might say, okay, but the LTO, everything is a storage medium. They put also zeros and ones, and they retrieve. We see it in the computer. I put my PDF, I put it in my external hard drive, take it home, and it's exactly the same. Yes, it's the same. But the difference is that film allows us to write human readable information. So at the beginning of each film, you have description of what is coming, what we call metadata. You can, for example, say, okay, I want these strange frames that have some files. I want it to be read by Japanese people. They are in English, but I want it to read. So you can print in human readable a dictionary, Japanese, English. So you can describe, okay, what you're gonna find in the future in this reel is a storage volume of the Second World War or whatever. So everything can be explained. We also write in code, like the programmers, the decoding software, because we're assuming in the future you find this reel. We don't exist. So you take this, what is this? The first thing you remember, you can read. You can take a loop and you start reading instructions. So you have table of content. And you say you can decode, but when you look into, you see some strange blocks and say, what can I do? So you see the commands of the decoding. So you call a programmer and say, could you please write this code on your computer? So he write the code physically, or he scan it. So he create a code. He compiled that in his operating system in the future. He have a C language, and then it comes a software. It comes a software that can decode these strange images. So he says, please scan these frames. So you find a scanner, you take pictures. It will take you a little while. You take 65,000 pictures. So it's actually an image. an image, so a lot of frames. And in this software that you made, that you have compiled, you say, put these frames. So you put the frames, and then appears your PDF, appears your TIFF files, your database. But then in the future, you cannot open PDF. You say, okay, beautiful PDF, but there is no software that open this. So in the reel, we can also put the file format specifications to create a reader of PDF.
Ah,
So you have the information of the decoding software,
yeah,
then you got files, and now you have the rendering softwares. So there is a lot of open source rendering softwares, guys that have created open source PDF readers. There is the standard file format. So if you tell me, Alfredo, what I want to preserve, I will tell you, well, put all your documents in PDF A, which is the file format that probably will last.
yeah,
And it's open. It's an open standard, so I can put the file format specification. But if you tell me, Alfredo, I want to put these drawings in AutoCAD, we can put it. We can put the decoding, but I cannot put the software to open AutoCAD because it's proprietary. We don't have access. So I
yeah,
can tell you, well, there is some open source in the market that can open these files. Do you want it? So you say, yes, put it there. So in the future, you have to do some archaeologic work, but at least you have all the information written. And that's what we call self-contained. If that happens with an LTO, magnetic tape, or with a USB or with a hard drive, it's not. If you don't have the technology that is able to read it, so you cannot put instructions attached to it.
yeah.
And that's one of the advantages of film, besides hardware of the hardware part, you know.
Yeah. Oh, amazing. Oh, I think Georgia did sort of give me a brief overview of that, but I didn't quite realise as to what level of detail you go into. Felt like what the fail-safe method for it. It's interesting you say that like an archaeologist of the future would have to have maybe understand programming language to be able to decode the information. Yeah, I mean, I guess maybe that leads me on to this idea of like thinking about it in the future. But before I go there, I just want another technical side of it. Your film not only has the different blocks of grey and white and black on it, but also you can put pictorial information on there, can't you? So
correct. We call it visual. Imagine like the old microfilm.
Yeah.
That was still images, you visual. So you can read. You read instructions. You read the code, and you read anything you as a customer want to put. So you can put your introduction, your logo, the company, who am I, what is this project, what you're gonna find. And then we also can write how you build a scanner, because all the technology is open. But of course, there is some assumptions. We assume there are computers in the future, and there are programmers, and of course there is going to be image capturing technology that can take a picture of that. If nothing of that exists, it's because we have been really going down in civilization. So, of course, it won't be possible to decode. We might use the film for making fire, something like that. But that's exactly as you say. We do this visual, and then we do these digital frames that basically is black and white and grays.
Is it possible to put whole feature films in their raw format into this format? Or would you just have loads and loads of film? Would it just be too much? So?
You mean in the digital format or in the color?
Yeah, the digital format on the film.
Yeah. It is possible. We can do any type of file because, as I explained, any file is a stream of data. So it's just zeros and ones. That's the language of the computer. It's not the one we read. So it could be a database, it could be a web page, it could be a sound, anything that is expressed on a file, because we don't need to render the file. We don't need to have software that understand the file. We just take it and we just take the stream of data and we build these squares that we call frames and we expose them. Then the way we encode it, we have a decoding software that can take it back and put it in that file format. and I might not have the reader. You just gave me anything that my computer is not able. We process it, print it, and when I retrieve it, I will get exactly the same. So any type of file can be put on it, and the raw is possible. You mentioned a point of the amount of film. Yes, it will be a lot, especially because the raw images are very heavy. So even today, they don't put it in LTO. They actually are compressing something that is called lossless compression.
Yeah.
So they try to lose the less information, compress it in order to make the masters, because the raw images will consume many LTOs. And by default, it will consume many piql films too. So that's a challenge.
Has the movie industry approached piql about storing movies?
Yes, we have some projects. As I mentioned at the beginning, it had started with audio.
Yeah.
And especially because of the size of these movies. So they start making analysis and they say, okay, audio is perfect. The size of the files are not that big. So we have started mainly with audio. Then trailers, we had small documentals, but big pictures still we don't have the density to make so many, to make it maybe cost effective.
Yeah.
Because we can do whatever. It can be huge, and then you have many rolls, many films. But then, is this cost effective? So today we have a roadmap to increase capacity, the density. Today we can do 120 gigabytes in one reel.
Okay.
When you compare to terabytes on LTOs or magnetic tapes with your hard drive. But then we have some roadmap to increase the density little by little.
Okay, great. And how does it make you feel, like working on technology that sort of will far outlive you?
I think it's very interesting. I think it's like contributing a little bit, and you feel this when you talk to archivists. They really see the value. They love it, love the concept, and then you feel, okay, this can be kept for generations. And now we are releasing pro. You hear that we open a vault in Svalbard, which is an island of close to the North Pole. It belongs to Norway, but it's all the NATO. It can be used by any of the NATO countries. It's demilitarized, and so we have some seed vaults. So we put now the digital archive vault, and then we have a lot of interested people putting their reels there. And like this, what we're trying is to be. This mine is owned by the government. It will be backed up by the Norwegian government, not by a small company in Norway. So, and this is your information. If we disappear, your information will be hosted there. You can go there, retrieve it, or you are the owner. And of course, Norwegian government has some renowned, how you say, is believed. The community, the international community, believe in the system, believe in that Norway at least is a safe country to safekeeping this. So that's the feeling. I think it's very cool to develop this technology. Hopefully it takes off as we want.
Yeah, absolutely. Yeah, it's great. Well, great. Well, thank you very much. I think that's a good place to end it. I don't think there was anything. It's been really fascinating talking to you.
You have a little bit of everything. I'm Colombian, so I like to talk. Yeah. Good luck with the documentary.
But thank you so much. Thanks for your time. Really appreciate it. All the best.
Bye.
See you. Bye.